We're going to talk about number pattern. We're going to talk about number pattern. We'll take a look into some revision 11. Revision of 11. Revision of 11. Guys, you need to know each and every tactic. You need to know each and every tactic when it comes to number pattern. Until there was a technique. Each and every technique you must know. Okay, I'll start with the quadratic number pattern. 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 Let's take a look at the general formula. Formula is Tn equals to An plus Bn plus C, An squared, right? Where there is a formula to find A, B, C, right? Let's take you have the first term, second term, and the third term. Here there is a formula for this one. It's A plus B plus C, right? Let's say this is the first difference. First difference. Where you subtract T2 from T1. Here where you subtract T3 from T2. But this one is not necessary because you're going to use the first value that you find here, and here you're going to equate the first value, which is your first term, right? 3a plus what? So 3a plus b, right? Yes. This is the formula to find b. You are going to equate it to the first what? First difference. Now let's go to the third difference, which is constant for quadratic number pattern, which will be the third difference. The third difference, which is 2a equals what? To your third difference. Your third difference is common in the quadratic number pattern. Your third difference is common in the quadratic number pattern. Let's take a look, guys. Most of you don't know that from the first difference, the first difference forms a number pattern which is called what? Linear. Tn equals to a plus what? N minus what? 1b. This first difference. It forms this number pattern. It forms this number pattern. The first difference of a quadratic number pattern, it forms a linear number pattern. Where A is a what? First term, right? Your D is a what? Common what? Common difference. Common difference. That's what you must know. That's what you must know. And N represents number of terms. Or terms. Represent number of what? Of terms. Of terms. Where Tn is the what? Nth term. Those are the two number patterns which are found in 11. These are the two number patterns which are found in 11. As I was saying, you must know that the first difference of quadratic number pattern forms what? Linear number pattern. Forms the linear number pattern from the first difference. The first difference forms linear number pattern. You must never forget that. You must never forget Grotov number pattern. Number one, I would like to talk about the arithmetic number pattern. The arithmetic number pattern. This number pattern is same as the linear number pattern, but here in Grotov is called arithmetic number pattern, where the general formula is Tn equals to a plus n minus 1 into what? N minus 1 close brackets d, right? Where I've shown there that a represent the what? First term. D represent what? The common what? Common term. And n represent number of term. Number of terms. Where Tn represent what? The n term. That's the arithmetic number pattern. You must know that if you have your first term, your second term, your third term, and your fourth term, your difference here, or to see that your number pattern is arithmetic, you will see that the difference is what? Is common. You see by the difference being common. That's how you determine that your number pattern is what? Is arithmetic number pattern. When your difference is common. Okay, let's also take a look into. You see the general formula, right? Tn equals to a plus n minus 1 plus brackets d. I want to make a number pattern in terms of a and d, right? You'll see. I'll come and say Tn, I'll put the first term equals to a plus 1 minus 1 d. That's one. T1 equals to a 1 minus 1? 0. N number multiplied by 0 is what? Is 0. Your first term is what? It's a, right? T2, a plus 2 minus what? 1 into d. You see? Whereby you have a 2 minus 1? 1 multiplied by d? D. This is your second term, right? Your third term, in terms of a and d, equals to 3 minus 1d. A plus 3 minus 2 is 2, right? Is 2d. Meaning that your number pattern can be represented as a as the first term, a plus d as the second term, a plus 2d. Guys, don't forget these things. This is how they want to trick you. They'll come and say find the value of g. When you are not given any number term. Now you have to work your things simultaneously. You must know these things. You must know these things. What else? Let's go to the other type of number pattern which is found in the top. Geometry number pattern. Which is the geometric number pattern. The general formula, general formula is Tn equals to a Rn minus what? Minus 1. That's your general formula for your geometric number pattern. Where also here a represents the what? First term. Now, this is where you see the difference between arithmetic and geometric. R represent common ratio. common ratio. This is how you will see that your number pattern is geometric. N represent number of what? Number of terms. Tn represent the what? The nth term. The nth term. The nth term. Now let's make a sequence in terms of A and R. I'm coming to say T1 equals to A, 1 minus 1, which is 0. A number to the power 0 is what? Mathematics students. Is what? A number to the power 0? 1. A, right? T2 equals to A r to the power 2 minus 1. A r. Remember? A1 determine number 2. A into r to the power 3 minus 1. 3 minus 1. 2. Now, your number pattern is AR, R squared. Is it? And our, okay, how do you find your R? How do you find your R, which is common ratio? You are going to see, you are going to say T1, let's say this is T1, this is T2, this is T3. To find the common ratio, you must say R equals to T2 over what? T1. This is your formula to find R. This is the formula to find R. This is the formula to find R. So now, we're going to put the R up on it. T2 over T1. Let's see. What is T2 there? What is T2 there? AR. What is T1? E. A and A will what? Will cancel. Your R is what? It's R, you see? So when we're turning a T3 and a T2. Use T3 and T2. Find your R. Use the T2 and T3 to find your R. Is it? Mathematic gymnastics. Real gymnastics. Real gymnastics. Let me see there. Susanna's ready. Look at his video. I'm just waiting. Is it? Ah, that's how we find out. Let you see. Let you say see. Let look. Let you say see. No. Let me see. Let me see. Seems like you're bridging. No. Seems like it's correct. Let me see. You didn't do any gymnastics there. Yes, guys. Do gymnastics, guys. Come on. I said, let me see. Okay. So here, AR squared over AR, right? A and A will what? Will cancel. Now you have your R2 over R. You are dealing with the exponents now. The top is same, the R and R, right? But this one is exponent what? 2. Meaning that in is this the denominator of the numerator? Your numerator has is same as r multiplied by r over what? R. You cancel over what? Your r, you left with r. There is a there are levels to these things. There are levels to these things. These are basic things. I'm going to series. I'm going to series now. Let's take a look into series. We are trying to expand our concept, whereby in the times where we're doing an example, we'll be doing like things with great ways. Let's start with the arithmetic series. Let's start with the arithmetic series. Here in series, the difference between a series and a sequence, you will see a sequence is more like 3, 4, 5, 6. Right? This is a series, right? But a sum, you see it by, a series you see it by 3 plus 4 plus 5 plus 6. Or 3 minus 4 plus 5 minus 6. In series, it's more like terms are being added together, right? But a sequence, you will see by these things. This is a sequence. A sum or a series, terms are being added together. Is it? That's the difference between a sum and a series. That's the difference between a sequence and a series, right? Let's go to arithmetic series. It has its own formula, right? The formula for arithmetic series is Sn n over 2 into 2a plus n minus 1d. That's your formula for arithmetic series. 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 Again, A stands for the first term, guys. N stands for the number of terms. D stands for the common difference. Common difference. Common difference. Common difference. Let's say you have a sequence of 6, 9, 12. No, you have a series of 6, 9, 12. You see? Remember now, you have a series of 6, 9, 12. What type of a series is that one? Is it a geometric or arithmetic, and why? How do you see that? It has a common difference of what? Of 3, right? 3, 3. You see that? Now you know this is your arithmetic what? Arithmetic series. It's an arithmetic series. And the question says to you, find the sum of 12 terms in this series, right? You are going to determine your A. You are going to determine your N. You are going to determine your D. Then you find the sum, right? Let's do it. Your A is what there? Your first term is what? 6. What is your number of terms? What is your number of terms?
1.
From the question.
12.
12. Is it? What is the common difference? 3. You see? Now you're going to find the sum of 12 terms. No? You're going to say Sn, write the formula first. Sn over 2 into 2a plus n minus 1 into d. Your n is what? It's 12 over 2. 2 into 6 plus 12 minus 1. Your d is 3. This is the sum of 12 terms. Okay, the lesson is finished now. Guys, don't forget to subscribe. Say it.
Don't forget to subscribe.
Yeah, thank you.
If you subscribe, you will regret.
Okay. Okay.